This is the do now for day 17. The answer is explained. For question number 1, it asks if the ordered pair 1, 1 is a solution to the equation y equals 6x minus 5. If you remember that a ordered pair has an x value and a y value. If we substitute the x value in the equation with our x value from our ordered pair, we should get y as an answer if it's a solution. So let's try this. Y is equal to 6 times x, we said x is equal to 1, minus 5. Well, 6 times 1 is 6, minus 5, 6 minus 5 is 1. Does that equal our y value of 1? Yes, it does. So yes, it is a solution. Look at question number 2. Do we get the same thing? If we plug in the values x and y, rewrite the equation x, well, x is positive 2, minus 5 times y, what's our y value? Negative 2. Does that equal 0? Let's find out. You do have to use the order of operations here. So the first thing you need to do is multiply your negative 5 times the negative 2. So 2, negative 5 times negative 2, and negative times a negative is a positive 10. 2 plus 10 equals 12. Does that equal 0? No, that does not equal. So no, it's not a solution on the second one. Let me do some erasing so we can do the next problem. For question 3, it says solve the following equation for h. That means we want to get that h all by itself. There's our h variable. The g is with that h, so we'll treat that almost like it's a variable term. The EF is outside of our circle, so we need to move that first. It's being added to my GH, or it's a positive EF, so what you would do is write GH is equal to, I believe that's an L there, L minus EF. Bring them both over together. Then finally we want to isolate our very important variable, that h, from its coefficient, which is the g that's right beside it. If it's beside it, we have to divide it. So you divide both sides by g. So your final answer, h is equal to 1 over g minus EF over g. Or you could leave it as 1 minus EF over g. That would be an acceptable answer for right here, but to get us prepared for what's coming next with our graphing equations, do separate it as two separate fractions. Question number 4. We have a complex fraction equaling another fraction. Remember, when you have complex, you have to cross multiply. And the arrows show me what I need to multiply what with. So on my left hand side, I should have 5 times k plus 1 is equal to, on my right side, 2 times k minus 8. Right, so after you cross multiply, the next step in CDICIC is distribute. Whenever you see parentheses, you have to distribute. So 5 times k is 5k. 5 times positive 1 is positive 5. Don't forget the sign there. Equals 2 times k is 2k. I don't need to write the sign in front of that because it's positive and it's the first term in the expression. 2 times negative 8, don't forget that sign, is negative 16. My next step is I need to identify my terms and making sure that I have variable terms on my left and my constants on the right. So here I have a variable term. There's another variable term. I need them both on the left hand side, so I move that 2k over to the other side as a minus 2k. And here I have a constant and another constant. I want my constants on the right. So I bring that positive 5 over as a negative 5. After you identify your terms and making sure that you have them on the left and right side of the equation, now I draw my big fat line and I'm ready to combine. When I combine, remember to use the rule of SOB. I have 5k and negative 2k. Those are opposite signs, so I have to subtract. 5 minus 2 is 3k. Don't forget your variable. Also, don't forget to bring down that equal sign. Then I combine the negative 16 and the negative 5. Those are the same sign, so I have to add. 16 plus 5 is 21, but don't forget the bigger sign wins, so it's a negative 21. Our final step is to isolate the variable from its coefficient. The coefficient of that variable is 3, it's beside it, so what do we have to do? We have to divide it. So our final answer then would be k is equal to negative 21 divided by 3 is a negative over a positive is a negative. 21 over 3 is 7. So k equals negative 7 is your final answer. And the last problem. You're graphing a compound inequality. Remember, when you have two inequalities, it's showing that it's in between, so this is an AND. We do expect that our arrows are pointing towards each other. To solve this, you need to rewrite the two inequalities separate from one another. Don't forget that minus 4 on the first one. It's that whole side and this side of the first one. And then your second inequality is that whole middle and this side here. So negative 4p minus 4 less than or equal to 8. Alright, solve each inequality separately. So in the first inequality, we need to, it looks like you need to identify some terms and get them on the same side of each other. Here we have a constant, there's a variable term and a constant. We want our circles on the left, so I'm going to bring that negative 4p as a positive 4p on this side, cross it off, and that negative 36 on this side as a positive 36. After you identify your terms, then you draw the big fat line and combine. 4p is less than or equal to, don't change that to an equal sign, make sure you use an inequality symbol. Combine those two terms together using SOB. Those are opposite signs, so you have to subtract is 32, but the bigger sign wins, so it stays positive 32. Final step is isolate your variable from its coefficient. There's a 4 that's beside it, so we have to divide it. It's a positive 4 that we're dividing by, so our inequality stays as it is, as a less than or equal to 32 over 4 is equal to 8. I'm going to wait to graph it until I solve my other inequality. So my other inequality, I have a variable term, a constant, and a constant. So the only thing I need to move is that negative 4 over to with my other constant as a positive 4. Draw my big fat line. I have a negative 4p less than or equal to, combine my 8 and my 4 together to get 12. Then I isolate my variable. I have a negative 4 beside my p, so I divide by negative 4, divide by negative 4, and this is where bells and whistles go off in my head when I'm dividing by a negative number. What happens to the inequality symbol? It needs to change its direction, so your final answer should be p is greater than or equal to 12 divided by negative 4 is a negative 3. Now you're ready to graph. We're graphing that p is less than or equal to 8 and p is greater than or equal to negative 3, and that's an AND. So when I graph this, I just simply plot my two endpoints. I plot the 3, and there's an equal sign underneath it, so it's closed. and I plot my 8, there's also an equal sign under it, so it's closed. Because it's an AND, that means all the values in between, or connect them together.